talk a bit more about biodiversity now. May I ask Damien, Demoor, Nicole, Yeomans, and Marie Thabard to join me on stage? Hello, how are you? Thank you for coming. So, Marie, bonjour. Would you like to grab a microphone? And we're still waiting for Damien Demoor. Ah, there we are. Sorry, a bit early, actually, for once. Thank you, everybody, for joining me. So most of us will probably have heard of so-called bubble curtains to block subsea installation noise. But French startup Greenov has come up with another idea, the so-called subsea quieter. Damien Demoor, you're the CEO of Greenov. So explain, please, what does that mean? What's the subsea quieter, please?
Yeah, I don't know if we can. I have got some slide. I don't know if.
Yeah.
Nice. So here you can see the first. It's okay.
Can we see the? Yeah, there we go.
Yeah. So you can see the first prototype of the system. So it's a system that allows to contain noise by reducing it by the using of underwater air that is entrapped into a membrane. That allow to isolate the pipe from the water and so to mitigate the level of noise. So if you can go to the next slide, so you can see the principle. So it's like socks that you deploy all around the pipe before to pipe drive it, and that allow with this specific fabric produced for this topic that allow to mitigate usually the level of noise.
And I understand you recently tested your technology, right? Yeah,
we made the first prototype at a small scale, for pile up to 2.5 meter of pile, and it shows pretty good efficiency. So I don't know, I've got the first movie to introduce the trial. I don't know if it's
Can we see the movie?
Feasible to put it.
Is that the one, or is it?
No, it's another file that was separate because we are asked to be separate.
Let's see if we can show the video, maybe. No video. Okay. I'm sorry.
So it was a test made early this year, and that demonstrates several things. The first thing that we are able to achieve 150 cycle of deployment and recovery. This means that around 150 pipe ride. And we are also able to measure the noise efficiency even at low frequencies, because you know that for pipe driving it's low frequencies that are the most impactful one. And so we were able during this test to measure this low frequency by using air guns, by using acoustic sources, in order to assess the efficiency of the system. So you can see there that there's 4 effects of efficiency. The first one is that we've got entrapped air into the panel that create a change of impedance 4 times repeated, and that allow to mitigate usually the level of noise, like bubble curtain, but a continuous thickness of bubble curtains and 2 rows of them. So 4 times better than the principle of bubble curtain. The membrane is also flexible, so part of the energy, acoustic energy, is consumed by transforming in kinetic energy inside the membrane. The membrane is made also of 20,000 yards per square meters inside the panel that maintain the thickness of the system, but also that allow to create a metamaterial effect. That is an effect that allow to reduce also the level of noise. And the last effect is that inside the membrane, between the membrane and the pipe, so in a very confined area, we've got a bubble curtain, a huge bubble curtain with a huge quantity of flow rate, 4 times the classical bubble curtain one, that is confined by the panel, and that allows also to improve the noise efficiency of the system. So in terms of efficiency, if you can go to the next one, this is the
Yeah,
this is a prototype and the movie that hopefully you can see on our booth after the meeting if you want. And then you will see the result that we publish officially for Seanergy this year. So if you can switch to the next one, please. So you can see there the noise efficiency of the system. So depending on the frequency, so at a very tiny frequency of 60 Hertz, we achieve to reduce the level of noise between 12 and 40 dB, meaning 97% of pressure level reduction. And when we put together both the subsequenter and the internal confined bubbling belt, we achieve at least 17 dB, which is very high compared to the existing system. And you can see on the table the performance is also at 100 Hz, 200 Hz, 500 Hz, knowing that this is a slow frequency that is responsible for the main impact of animals of underwater noise. So we've got results better than the numerical modeling that we forecast, so that's a very good thing. Better than the current system, even at low frequency, and we've seen also that this confined bubble curtain is much more better and improve again the efficiency of the system.
So, good results. What kind of projects are you working on? Where will this be deployed?
So if you can switch to the next one, please.
I will.
So we are currently working on the design of the system for big monopile up to 12 meter depth diameters and 60 meter depths. So this design is an ongoing one. And if you can switch to the next one, you will see what is the next step. So we are working with some partners within GIP. So the current partners are EDF, Total, and Equinor. So they found us and they bring also their expertise and their validation. So that's the end of this phase one, and then we'll have several phases: phase of design, then phase of demonstration in 2026 at real scale on big monopile, in order then to be able to provide a solution for all the coastal and offshore works.
What kind of countries are you looking at? All sorts of countries, or?
We are working with a lot of partners, and hopefully that some new will join the GIP in the next weeks and next month. But we are currently working on a US project, on a European project also, and we start to look at the ASEAN one.
Great. Well, thank you so much, Damien Demoor.
Thanks a lot to you.
Nicole Yeomans, you might at one point possibly analyze the effectiveness of the subsequenter with what you're doing. You're offshore lead at UK-based nature data company NatureMetrics, and your company has come up with a new way to monitor sea life. Tell us more.
Yeah, so we're a nature data intelligence company that takes the complexities of life and transforms them into data through our DNA technology. So we then convert that data into metrics that can then be used to monitor ecosystem health over time. And we're working across 100 different countries at the moment, with over 500 clients in many different sectors, including conservation and port monitoring and offshore wind. So one of the key projects that we've been working on within the offshore wind sector has been with EDF Renewables and Natural Power, where we actually compared DNA technology against traditional trawl surveys, which are often very destructive. And we found that the data collected using the DNA technology was absolutely mind-blowing. Like, we were able to detect so many different species. It required a lot less vessel time and personnel. And with one sample, although we were looking at fish in particular, we were also able to collect data on marine mammals and seabirds and really get a snapshot of the biodiversity at that time. So it's a super exciting project. And yeah, we're looking to expand that project. It was undertaken over a whole year across different seasons. So we have a really exciting data set from that.
You're taking the water, right? You're also taking sediments, or how does it work exactly?
For this project in particular, we're just looking at water, but you can absolutely take sediment samples as well, so you can get a real good understanding of the benthic communities and compare it against traditional taxonomic surveys as well.
Mm. And so you mentioned a project you've been working on. You've done a case study at the 41.5 megawatt Blythe offshore demonstrator of Northumberland in the North Sea. are you deploying a system already at other offshore wind farms? What's planned?
Yeah, so we've actually been incorporated quite heavily in the baseline assessments of offshore wind developments within the North Sea in particular. We're now starting to see that regulators are advising that eDNA surveys are done alongside traditional methods to help future-proof those developers.
And do you have, I mean, with your system, can you actually assess the impact of offshore wind farms on sea life, or how close are you to that?
Well, with a lot of the projects that we've been involved with to date, it's still early days to get a real good understanding of those impacts, because we can only tell this really over time, but because the Blythe Demonstrator project was done through a whole year across different seasons, we actually got a really interesting data set where we were able to see that particular species, including bottom-dwelling fish, actually were using the turbine arrays more so than other areas outside of the arrays, and we saw a greater relative abundance of those species within the turbine array, and the same for key fishery species like cod. They were using the turbine array more so than outside of the turbine array during their spawning season. So that was giving us a really interesting results, because you can interpret that as maybe the turbines are giving a reef effect to those species. But as we say, you know, it's better to get more data over time, but so far they're really interesting results.
And I understand that innovation is really at the core of your system. What kind of technology are you using and deploying?
Yeah, absolutely. So we've developed a nature intelligence platform and a suite of metrics that allows us to bring that often traditionally dry eDNA data, which is just a list of Latin names in an Excel spreadsheet, and really bring it to life so it's meaningful and engaging to a range of different stakeholders. We've developed a suite of different metrics, including fish metrics, that allowed us to assess food chain integrity, the prevalence of sensitive species, species of high commercial value. So these metrics you can then use to understand how the ecosystem's changing over time in a way that you can communicate to a wide audience, in particular the fishing community as well. And those metrics also support companies on their disclosures and reporting. So particularly the Task Force for Nature-Related Disclosures, we can use metrics to support their reporting, and also companies' own nature-positive targets too. And we also have recently launched an autonomous sampler that gives you high integrity data that you can deploy within the turbine arrays themselves, or you can attach it to an ROV. Again, saving on vessel time and personnel and costs, giving you that real high integrity data. So you know, this solution is a market-ready solution that can be deployed at scale across your portfolio, and it can be used really to support the monitoring, measuring and protection, as well as restoration of marine biodiversity.
Oh, thank you so much.
You're welcome.
Thank you. Marie Thabard, these technologies could be something that could obviously of great interest to you. You are head of development at Spain-based Iberdrola, and which is developing, as we know, the 496 megawatt offshore wind farm Saint-Brieuc. Before we get started on the biodiversity part, can you just give us a very, very quick update on where your project is at right now?
Oh, yes, of course, about the project of Saint-Brieuc. So it was commissioned and finalized end of May. So all the turbines are now producing energy for Brittany. And we are now switching onto the O&M phase. So ready to start for 20-25 years of O&M phase. And one of the big steps is occurring right now. It will be the opening of the site for the sea users. So this is one of the last steps we engaged to, and we are now achieving with sea users, but also with the French state that it is involved on taking those decisions.
And so biodiversity, what kind of measures are you putting in place to protect that biodiversity at Saint-Brieuc?
So what needs to be done, to be known, is that there is a frame in France and like in every other countries. Of course, you don't build such project without studying the environment initially and without putting measures in place. So for Saint-Brieuc, we had an environmental impact assessment that was done back in 2015 based on measures done in 2012 and 2014. So we can see it was a long time ago. Those projects are so long that we need to actualize this. So this was done again between 2018 and 2021 before we started the construction of the offshore wind farm. And of course, there is a full monitoring program during construction phase and during operation and maintenance phase. For the program of Saint-Brieuc, we have around 40 measures that are linked to environment. This goes from studies about birds, about marine mammals, fish you were talking about noise. This was a really interesting topic we worked on the Saint-Brieuc project. And all together, so we put all these surveys, and the objective is to identify what is the impact on this environment and to ensure that what we had planned ahead with this environmental impact assessment is really what is occurring on the environment.
Is that so far the case? Do you have any results yet that you can share with us?
So we've been doing monitoring for the 3 years of construction. As I told you, we've just finished, so I don't have the full package of consolidated data. Of course, it takes time. But yes, we have first results. And so far, we can see that what we had predicted in the environmental assessment is somehow what we measure on the field, so we don't have a drastic impact on the environment today.
All right. Some of you might have seen the news recently in the French press, at least, of waste accumulating in the jacket foundations at Saint-Brieuc. Now, when I saw this, I thought, well, that's quite practical. It cleans the ocean, but obviously it also has an impact on your project development. It means additional costs, right?
So I wish we could do everything with turbines and even clean the environment, but this is not the case at all. So yeah, what occurs is that we have those structures that are in the marine environment. In Saint-Brieuc, this is one of the locations where the tidal regime is the biggest in the world. We have a lot of currents, so we can easily understand that a lot of things can just drift at sea and accumulate onto the structure. So indeed, it could have an impact on the operation and maintenance because it could reduce our capabilities to approach the structures. Now we have launched so Iberdrola is driving a program for economical development with the region of Brittany around the project of Saint-Brieuc, and the objective is to have some specific programs in terms of innovations that are being performed. And so we had launched a tender and a call for projects back last year with the Polmer Bretagne Atlantique. And 2 bidders have won the prize about this specific question. One of them is Actima, and he's working on a modeling to understand how those objects are drifting within the wind farm. So we have just launched the studies. And the second one is Efinor, and it's working on a solution to collect those drifting objects and to help us to maintain that wind farm.
Were you expecting that side effect at all or not?
As you may know, Iberdrola has other wind farms elsewhere in the world, in the UK, in Germany. We are building in the States now, and the phenomenon we observed in Saint-Brieuc was a bit higher than elsewhere, but we believed, yes, those currents were particularly high in Saint-Brieuc, and so this is part of the explanations, yes.
You just said Iberdrola obviously has projects in other countries. What other kinds of measures are you putting in place to protect biodiversity around the world?
So there is a specific team at Iberdrola that is taking care of all the environmental aspects of the project. Maybe I could say, some measures are concerning the observation of birds and of marine mammals through plane observations. And there are typical measures that you can find on different projects. For the program of Saint-Brieuc, what I can tell you and what Iberdrola has put in place is that we have put a lot of measures, even beyond what the authorization were telling us to do. For instance, on the noise, to come back to the initial topic, we have been in discussions for years with Damien because initially, for the program of Saint-Brieuc, we had to test an innovative measures for pile driving. It happens that in the end, we did not do pile driving. We went even beyond these measures that was needed to be applied on some piles, and it would have reduced noise on some piles, but we wanted to go farther. And what we have done is that the project of Saint-Brieuc is one of the first wind farm built fully drilled. So we have completely changed the method of installation to really take care of the environment and the biodiversity.
All right, well, thank you so much. Thank you, everybody, for taking part, and thank you for listening to this panel.